Good afternoon, everyone. Thanks, Jay. I'm Dave Rigg, and I'm the Chief Operating Officer for Bombora. Okay, so Bombora is primarily a wave energy company. We're based down in Pembroke Dock in Pembrokeshire, and we've got a great team down there, 27 staff, but we are growing the team. And so if anyone is interested in joining our team, please do get in touch afterwards. Offices overlooking the Cleddau River, and we do have a few remote workers across the world as well supporting us, but most of the team are based down there. And the project that we are primarily focused on at the moment is also based down in Pembroke Dock. So the technology, well, we have our own proprietary technology, and it's very novel. It sits below the seabed, and it consists of a number of cell modules. And each cell module is like, it's effectively a large steel bathtub, and that structure is encapsulated with a large, flexible rubber membrane. And all of those cell modules are linked up to a central ducting system, which has a turbine within it. As the waves pass overhead, the varying hydrostatic pressure field causes these membranes to inflate and deflate, effectively like large bellows, and the air is driven through that ducting system, turns the turbine, turns the generator, and turns the lights on. So it's a relatively simple concept, and the only moving parts exposed to the sea are that membrane, which is, very robust, and we formulated that rubber to be very robust, and it's not, the subsea environment doesn't cause any corrosive effects. So we also have a survivability mechanism that enables us to evacuate the machine, effectively lock down the membrane and the turbine, the generator, during some of the sort of more dynamic sea states that we will see in storm events, so that we can cap the loading and improve the survivability of the machine. So because the technology is very modular, we can take it and we can apply it to different architectures. The project that we're developing down in Pembrokeshire is a fixed seabed architecture, but equally we can take that cell module and the associated powertrain and apply it to floating platforms, which obviously enables us to harness more dynamic wave environments and gives us access to bigger seabed leases. And we can take those structures and we can intersperse them with wind farms, which enables us to increase the yield per square kilometre of those lease areas, capitalising upon some of the shared infrastructure, or we can go a step further and we can actually integrate the wave technology into the platform and combine it with the wind turbine, and we'll talk about that in a moment. So the project in Pembrokeshire then. It will be a 1.5 megawatt machine. It's a £20 million project, and we've benefited from £13.5 million of funding through WEFO, and I'd like to thank them for their support to date. But there's also been a lot of private investment that's helped to fund this project. We are currently in the final stages of assembly, lots of testing and dry commissioning going on at the moment, and later this summer we'll deploy the machine off the coast of Pembrokeshire. This is what it looks like, and the objectives of this project are limited. We're here to demonstrate the technology, prove the power curves, demonstrate the survivability of the membrane and the O&M concept. And so we only have 4 cell modules on this machine. The other bays that you see there are used for ballasting the machine, keeping it anchored to the seabed. But it is very large, 75 meters long, 17 meters wide, and 850 tons. So it's an impressive structure, and later this year when we take it down to the slipway, it will be an exciting moment for all of us. This is the assembly hall that we're using, courtesy of Mainstay Marine. We have currently most of our technology is crammed into that assembly hall, and the guys are going through the dry commissioning. you can see two of those cell modules there under assembly. This machine's been very useful to us. This is the boat hoist, but it's proved to be a very cost-effective way of safely and efficiently moving large loads around the site, and it's a concept that we're likely to take forwards. So once the machine is completely assembled and tested, we'll take it down the slipway on a high tide, and despite it weighing 850 tons, we will be able to make it buoyant by inflating those membranes, which enables us to tow it to site and utilize relatively small workboats, which is one of the advantages of this concept. And there you can see, so we'll tow the machine through Milford Haven about 10 nautical miles round the Angle Peninsula, where we will then hook up on moorings. I say we, Liska doing this for us, so it will be Ollie in charge, I hope. And at this stage, we will deflate the membranes and manage a controlled descent to the seabed. A controlled descent, Ollie. Okay, in parallel, we're working on a project with Technip FMC and one of our more recent investors, Mitsui OSK Lines. And this will take our technology and integrate it into a floating wind and wave platform. By sharing key infrastructure, we'll be able to offer a proposition with a lower overall cost of energy. We'll be able to generate a higher yield per kilometre squared, bearing in mind these large floating wind turbines have a very large spacing, and so maximising the utilisation of that seabed is important. Reduced environmental impact per megawatt, improve the power consistency, because although wind and wave power are associated, there is a lag between the two, and so by combining them, you can improve that generation profile. But we'll also be able to operate in more exposed environments, because it's a larger platform designed for more dynamic wave climates, and so that will give us access to environments that traditional flow won't be able to access. And ultimately, we hope to be able to offer projects with higher returns and overall a more competitive bid. So this is the key. How do we get to commercial viability? It's an expensive business. There are a number of stages that we've got to step through. We can't go straight to the gold-plated solution yet. There's a lot of technology risk still to overcome. And so later this year is the first step. We'll demonstrate the technology at full scale. We'll prove that power curve, demonstrate the survivability of the membranes, and demonstrate that O&M concept. Then we take that technology and we integrate it into one of these combined wind and wave platforms through the Inspire project. Our modelling shows that we reckon we can achieve 170 euros a megawatt hour on that project. So still expensive, but bearing in mind this technology's got a long way to go. The supply chain is still relatively immature when it comes to this membrane technology that I'm talking about. Most importantly, that project will demonstrate that this combined concept offers projects with higher returns than a floating wind turbine on its own would do. And it will be key to securing that large industrial partner that we will need to go to the next phase. The next phase will be a small commercial array. It will further demonstrate the scalability of the technology, will bring the supply chain with us, and achieve or capitalize upon the learnings that we will have secured on that first project. And all of this will help to bring the cost down. And that cost reduction curve will be steep because there will be lots of learning and lots of innovation. From there, we can point to other similar industries that have been through this process, where economies of scale kick in. For example, fixed offshore wind. For the last 20 years, they have seen 15% learning rates, which means that every time production volumes double, costs have reduced by 15%. If we apply that formula to our technology, we will quickly see it competing with other more traditional renewables. So where do we achieve parity with the energy market? our assumption is that it's going to be around 80 euros a megawatt hour in the future, and we anticipate that to be around 2029. So there's still a long way to go, and it's this zone here that's the difficult bit, because these projects are expensive. The power that we generate is not going to cover the cost of the projects. So they're going to have to be funded through private investment, but also it's quite likely that we're going to need government support, some form of CFD to enable us to grow this industry. And therefore, the public are going to end up having to bear a cost for this. And so it's incumbent on us to promote what we do and showcase this industry, to promote the idea that we are building a new industry, we are generating high-value jobs, and we are establishing ourselves as world leaders, which will mean that these export opportunities actually come to fruition. But of course, we are also addressing climate change, and we are also addressing the need to reduce our dependence on oil and gas. And if there's one thing good that comes out of this horrific war in the Ukraine, it will be that nations all over the world will double down on their efforts to reduce their reliance upon oil and gas and to invest in local resources. And there's a lot of marine energy out there. Okay, that's all I have. I'm more than happy to take questions later. I think that's the format. Thank you.
Thanks very much for that, Dave. And yeah, if anybody wants to find out more about Bombora's technology, please, by all means, come and have a chat to Dave at some point during the conference. We look very much forward to seeing their M-Wave deployed, hopefully later this year, in Pembrokeshire. So up next, we have Richard from Hydrowing. Hydrowing are berth holders at Morlice, so we'll be bringing their technology to the coast of Anglesey. They'll be using Takado turbines, which are some of the most tested turbines in the tidal stream sphere. So over to you, Richard.
Thank you, Jane. Good afternoon to everyone. Very much enjoyed my little visit to Wales, particularly to see what's happening at Morlice and all the exciting developments that are happening locally. Now, first step is to try and work out how this works. Since 2007, I've been working in my first project in the tidal energy sector. That's quite a long time ago, and I've always felt frustrated that the sector hasn't really proliferated the way it should have. We've had all the big investors, all the big names come in, they've come in and left. And in 2015, I had found myself with a bit of spare time, and I thought how to address this problem. I've always felt that tidal energy has got huge potential. There's absolutely no reason why it shouldn't be commercially exploitable. And with that belief, I started to develop this idea called hydrowing. So basically, the key challenges we have to overcome and the key issues I saw in tidal energy over the years I've been involved is, first of all, the high capital expenditure, overly complex solutions, trying to go too big, too fast, and trying to not having a viable operation and maintenance solution where I saw the big issues. So we developed an idea developed a small team, and we started coming up with ideas how to solve these problems and how to tackle these issues. And what I felt needed to be, what we needed was a holistic solution where everything is considered, not just the turbine, the whole system, how we're going to deploy it, how we're going to maintain it. Everything needs to be considered in the design. So we came up with this idea for the hydrowing device, which is shown on this animation. So basically it's a multi-rotor device. We're using the Takado turbines, which are the most proven and reliable turbines on the market, with over 50 running years. And we're using a lot of the ideas that we've developed from our OCP project in the Netherlands, where we're achieving very high availability and very high yields. The device consists of two wing-like structures with multiple turbines, which are wet mate connected. Takado has the bi-blade system, which basically is a passive pitching system. So each time the tide changes, the blades flip round. And this eliminates, it just takes complexity out. The turbines are direct drive. They couldn't be more simple, and that's the main reason why they are so reliable. We also have our own operation and maintenance platform. We acquired last year a DP2 vessel, the Nyanga Encha, which is a highly efficient and very, very cost-effective tool for doing the operation and maintenance programs. And I felt this was really a key thing we needed to address because the vessel markets at the moment have gone absolutely crazy, and day rates on offshore construction vessels have more than doubled in the last 2 years. Not to mention the fuel consumption that these things burn as well. It just meant that our sector was completely unviable with the methods we've been using. We're looking at scaling the device up, so we originally envisaged starting with our T2 turbines, which are the same as the OTP, but we're now looking at building it using the T2SI, which is the next generation turbine, which is approximately 400 kilowatt device, using very much the same sort of technology, but with more enhanced blade design and a better smart overdrive system. Moving on, as I mentioned, the Takado Turbine. So we're a partner with QED Naval and acquired Takado and resurrected the company from bankruptcy and rebuilt it, and that's been a fantastic investment. Really, really pleased with the deal. We're making really good momentum and getting that up and running. We've set up a UK branch for Takado to support our projects here in the UK. And we have workshops and facilities in the Netherlands, just north of Amsterdam, in a place called Veringenwerf, excuse my pronunciation. And then we have our OTP project, which is operating in, which you can see at the picture at the bottom, which is operating in the south of the Netherlands. We also, as I mentioned, acquired our DP2 vessel, the Nyanga Encha. She's currently out working on a project in northern Spain at the moment, and so bringing in good revenue into the business. But ultimately, our main strategy for this vessel was for it to be the installation, operation, and maintenance platform for our technology. She's a very unique vessel. She is a DC electric hybrid drive and very, very low fuel consumption. So typically, in a day, we'll be burning around 3 cubes of fuel a day, whereas most of the big construction vessels we're using are anywhere between 14 to 20 cubes a day. So massive fuel saving. The OPEX of the vessel is relatively low, and she's got very, very high, very impressive DP performance for working in high tide races. She's capable of doing the operation and maintenance, cable laying, foundation installation, all of the operations we need. And we also use the vessel for supporting our own customers and use it as part of our collaboration on other projects. I've put up there some of the advantages of our hydrowing system, which I won't go into too much detail about, but the key advantages is we're using a very reliable turbine. We have multiple turbines. If one fails, it's not the end of the world. Having said that, we've never actually had a failure in the turbines themselves. The electrical systems are very accessible, very low cost to recover the turbine to surface and access any electrical faults. And the logistics are very simple. Our new generation T2SI turbines are 20 tons each. They fit in a standard 20-foot ISO container, so can be shipped and moved anywhere in the world. So relatively simple, using just standard dockyard equipment that is available anywhere in the world. A little bit about our LCOE impact. One of the key things I wanted to address was the installation and OPEX costs. And with the modeling that we are doing using our own vessel, we're totally in control of the costs. We know what it costs. We know what the reliability is like on our turbines. Our estimates on for let's say a 100 megawatt array is that our installation costs are approximately half that of offshore wind per megawatt installed, and our OPEX costs are definitely on a par with offshore wind. Other areas we have to address is obviously on the CapEx and things, but that comes with scale, so we're confident that we are on the right path. We're also, as you may have seen in the media, we're one of the berth holders at the Morlai site, so we're very enthusiastic about developing that. We see that as our main focus for developing projects. We do have other projects in the pipeline that we're developing, but this is probably our preferred option at the moment to demonstrate and prove our technology at a reasonable scale. We're very keen to demonstrate our T2SI turbine, and as the site is not particularly high yield site, we're looking at some innovative features around blade design, about improving our passive pitch system and in order to extract a maximum yield from each of the sites. We're also working very closely with the local supply chain, and we're very keen, and part of my main mission here is to engage with supply chain companies in the area, particularly around areas such as fabrication, ports, systems integration, OEMs, fabrication, assembly, survey, and environmental consenting. So these are the key areas that we're keen to engage with supply chain companies that have that capability. I think that covers everything I want. If there are any questions, we are on stand 3 downstairs, so do feel free to drop by and have a chat at any time. Thank you very much.